sklearnnaivebayes. Description naive Bayes is a probabilistic machine learning algorithm based on Bayes' theorem that is used for classification tasks. It assumes that the features are independent of each other given the class label. This means that the presence of one feature does not affect the probability of another feature occurring, given that the class label is known. Inputs: X, the feature matrix. A 2D array where each row represents a sample and each column represents a feature. Y, the target vector. A 1D array containing the class labels for each sample in X. Outputs: Y, PRED, the predicted class labels for new data points. Probabilities: the probability of each class label for each new data point. Steps: Training: the algorithm learns the probability distribution of each feature for each class label. In the training data, this involves calculating the prior probabilities of each class and the conditional probabilities of each feature given each class. Prediction: given a new data point, the algorithm calculates the probability of each class label given the feature values of the data point. The class label with the highest probability is predicted as the class label for the new data point. Metrics: Accuracy: the proportion of correctly classified instances. Precision: the proportion of correctly predicted positive instances out of all predicted positive instances. Recall: the proportion of correctly predicted positive instances out of all actual positive instances. F1 score: the harmonic mean of precision and recall. Visualization plots. Confusion matrix visualizes the performance of the classifier by showing the number of correctly and incorrectly classified instances for each class. ROC curve plots the true positive rate against the false positive rate for different thresholds, allowing for the evaluation of the classifier's ability to distinguish between classes. Fine-tune parameters. Alpha, the smoothing parameter for the probability estimates. A higher value of alpha corresponds to stronger smoothing, which can help to prevent overfitting, especially when there are few samples in the training data. Fit prior, a Boolean value that determines whether to learn the prior probabilities of each class from the training data. If set to false, the prior probabilities are assumed to be equal for all classes. Uncertainty methods. Confidence score: the probability of each class label, which represents the classifier's confidence in its prediction. Entropy: a measure of the uncertainty of the prediction, where lower entropy indicates higher confidence. Challenges and fixes. Challenge 1: 0 probabilities. Naive Bayes can encounter 0 probabilities when a feature value is not present in the training data for a particular class. Sample use case that resulted in Challenge 1: a spam detection model trained on a dataset where the word Viagra is only present in spam emails. If a new email contains the word Viagra, the model might assign a 0 probability to it being spam, because it has never seen this word in a non-spam email. Fixes to Challenge 1: Laplace smoothing or add 1 smoothing. This involves adding a small constant value to all probability counts, ensuring that no probability is ever 0. Challenge 2: Feature dependence. Naive Bayes assumes that features are independent of each other, which might not be true in real-world scenarios. Sample use case that resulted in Challenge 2: a credit card fraud detection model trained on data where the feature's transaction amount and transaction location are dependent. A large transaction amount in a foreign country might be more likely to be fraudulent than a small transaction amount in the same country. Fixes to Challenge 2: consider using more advanced methods like tree-based classifiers or support vector machines, which do not make this assumption.